My name is Žuljević, and I'm a software developer at Levi9. And to give you just a little bit more background, Levi9 is a company in IT services. We have around 500 developers with development centers in Romania, Ukraine, and Serbia. And for the last few months, together with my team and our partner, Improve Digital, as a part of an open source initiative here at Levi9, we've been working with Samza, and also we have been contributing back to the community. We've been doing so by submitting patches. We've submitted dozens of bug fixes, dozens of improvements, even several features. So, what am I going to talk about today? First, I'm going to give you some background, how things are done usually, how we do them. I'm going to give you a short introduction to Kafka. I'm going to introduce Samza to you, and after that, I'm going to talk a little bit about what we have learned by using Samza. So, if you're doing any kind of processing with, let's call it large data, it's not big data, it's large data, then this picture should be familiar to you. So, what's going on here? We have some data on some servers. It doesn't matter where. There is some data that you need to get into your application. You do some batch processing with it. That's this part here. And then you have to enrich your data with some metadata that is not in this pipeline. So you have to get it again. And then when you're done, you put it into a relational database. Sounds familiar, right? And this is more or less how we do things at Levi9. Right now, we're downloading data from a server. It's already aggregated though, because raw data, it's, I don't know, terabytes of data per day. And every day we use this data to put into a relational database, but always we have to put some metadata in, like IDs and so on, so we normalize the data. And doing things this way, well, it introduces an artificial latency. What do I mean by that? Well, we do it once per day. It means the data comes in 1 day late, right? And if I learn that something happened yesterday, okay, that's nice to know. Okay, my servers failed, I lost some money, it happened yesterday, now I can't do anything about it, it's in the past, but it's nice to know. But what if I could know that it happened 15 minutes ago? Then maybe I can do something about it, right? I could get back that money, I could fix that bug or something like that. Sorry, fix that feature that I introduced and get the network working again, right? And to quote Gary Turkington, he is the CTO of Improve Digital and also author of books such as Hadoop Beginner's Guide and Learning Hadoop 2. The goal is to move away from historical data and to make data more actionable. And how do we do that? Well, by using streaming frameworks and doing some near real-time processing. First framework that I would like to talk about is Apache Kafka. It is a project started at LinkedIn that was later donated to the Apache Foundation. And what is Kafka? You can imagine Kafka as a distributed commit log. So, what is a commit log? Most of you probably know. But just imagine it as a file that lists all your transactions in a sequential order. That's basically a commit log, and that's basically what Kafka is in the narrowest possible sense. On top of that commit log, Samza gives you some functionalities like a traditional messaging system. You can query the data in the commit log, you can put something in the commit log, it acts just like a message queue, so that's why it's called a messaging system. But Kafka does all of this with a little twist. But by default, Kafka is distributed, Kafka is partitioned, and Kafka is replicated, meaning that no data will be lost. But also, what's the biggest difference from traditional messaging systems is that each message is persisted to the disk by default. What does this mean? It means that no message will ever be lost because it's persisted to disk, it's replicated, and it allows Samza to, let's say, guarantee that each message will be delivered at least once. And I do emphasize that at least once. You may maybe get it once, twice, 5 times. So you have to guard against that. And also another thing that comes out of this feature of Kafka is that messages can be read in any order. So you can start reading at the end, read them to the beginning, or start at the beginning of time, read them to the end of time, doesn't matter. Kafka allows all of that because, as I said, all the messages are persisted to the system. And just so you know, the feeds of messages, the messaging queues in Kafka are called topics. It's important that you know that because I'll be using that word, sorry, a lot. So how does a Kafka topic look like? As I said, by default, Kafka is partitioned. As you can see, there is only one Kafka topic, and there are partition 1, partition 2, and partition 3. And you can have an arbitrary number of partitions. Usually, it's the best thing is what you can do is to have as many partitions as you have Kafka brokers. A Kafka broker is simply a machine that holds Kafka partitions. That's what it is. And so I said also that Kafka is replicated, and by default, each message is replicated twice, or it's kept on 3 machines. So each replication, each partition, sorry, has a leader, and then from this leader, data or messages is replicated to 2 followers by default, or as many followers as you want. And that ensures that data is always available. If a leader fails or a Kafka broker fails, then a follower will become a leader, and then on another Kafka broker you will have another replication. And what's important to see here is that each Kafka broker has only one leader, as you can see. This ensures that whenever a machine fails, only one leader can be affected and only one partition is affected at a time. Also, what's important to know is that Kafka, as you can see, you have partitions, and then how can you send messages to a particular partition? And because this is how Kafka achieves parallelism, and very few messaging queues or messaging systems, are in fact parallel. And Kafka achieves this by allowing you to either send messages to partitions manually, so you can say, okay, I want to send this message to partition 1, or I want to send this message to partition 2, or you can partition by keys. So let's say, okay, something with the color blue, it goes here, with the color red, it goes here, with the color purple, it goes here. But also Kafka allows you to do the following thing. You can just send a message, not specify a partition nor a key, and the message will go basically to a random partition, but it all happens in a round-robin fashion. And so the first message will go to partition 1, the second to partition 2, the third to partition 3, and then back again. And also you have partitioning by failures, but it's not so important for this talk. So in the Kafka world, you have applications that consume messages, they're called consumers. And you have applications that produce messages, they're called producers. And it's also important because I'll be using these words a lot, and it's important for me to understand what producers and consumers are. So, producers, as it says right here, they can only append at the end of the commit log. And it makes sense, right? If you could append, let's say in the middle, then ordering will be lost. And also, it's very important to only append at the end, because each message in Kafka receives a unique offset, and this offset is always increasing. So in each partition you have an offset, and then this offset can be used by the consumers to read from any position in the message queue and to read in any order that they wish. They can read, let's say, message 10 now, then message 5, and so on. It doesn't matter to Kafka which way you use it. And these features are the things that Samza leverages the most. Apache Samza is also a project started at LinkedIn. It started, let's say, in parallel with Apache Kafka and was later donated to Apache Foundation as well. It is a stream source agnostic stream processing framework. What does that mean? It's a big word, right? It means that it doesn't matter where the messages are coming from. just as long as they are coming. But Samza is tightly integrated with Kafka, and it is the goal, the eventual goal of the Samza community to move all the way to Kafka, because this will ensure that the code is more compact, more simple, and so on. But by default, because Samza leverages Kafka so tightly, it ensures that Samza is fault tolerant, durable, scalable, and pluggable. But it has all these features, but it offers a really simple API. If you want to do something using Samza, all you need to do is implement one interface that has a single method, and it accepts 3 parameters, and it's really, really easy. And I'm going to show you just how in just a minute. Sorry, no, okay. And how do Apache Kafka and Apache Samza integrate? Those of you who know me know that I'm a huge Lego fan. I never miss an opportunity to play with Legos, and I do believe that everything you do, you should put a little bit of yourself. So this is the little bit of myself in this talk. So let's imagine for a moment that somebody gave you a nice little pile of Legos. It's probably unordered, unorganized. It's just bricks one on top of another. And then you want to store it in some box. In this case, these bricks are messages that are going to be stored in a Kafka topic. This is our box. Then we take these messages, these bricks, then we play around with them, we make something out of them. This is what Samza tasks do. And if you know a little bit about Legos, then you know that you have to have a basic idea of what you need to build, but also you have to take bricks by brick. And then what you have assembled so far, you have to keep by hand, right? And this is why it's a little bit obvious maybe that Samza also allows you to store state. After you have done playing with your Legos, you can put them back in some box again, in this case, of course, a Kafka topic. And that's all nice and well, but let's take a look how it actually works. So again, we have this nice little pile of Legos, and now our Kafka topic is partitioned, right? You remember that? And how this time we have decided to partition by the color of the brick. So in one partition go all the yellow bricks, and on the other partition we have all the red bricks. And as you can see, this is a Samza job, and each Samza job has one or more tasks, and each task has its own container. It's a machine that, let's imagine it like a machine that Samza is running on, and for each partition, as you can see, we have one Samza task. If we had 3 partitions, then we would have 3 Samza tasks. If we had 2 Kafka topics, each with, let's say, 2 partitions, then we would have 4 Samza tasks, and so on. And so, the first Samza task, it is collecting the messages, the bricks, from the first partition. It's storing them locally, the information about these bricks, making some models, and then passing the complete model to another Kafka topic that this time has the same number of partitions, but it doesn't have to have the same number of partitions. Similarly, this partition, the messages from this partition are going to this Samza task. Again, they are stored, and then later the complete models are sent to different Kafka to the same Kafka topic with different partitions. So, as you can see, this Kafka topic here, the partitioning is done by the type of creation. Let's say it like this. And the one and most important thing that you can see here is that each Samza task consumes exactly one partition from a particular Kafka topic. Okay? If we had 2 Kafka topics, then this Samza task would still be reading from partition 1 from this topic, but also reading from partition 1 from the other topic, in the case that this Samza task decides to consume more than one stream. And also I'm going to show you this a little bit later how it works. But it's very important to notice that right here we have a Samza task that is consuming from one partition, but it is free to send to any number of partitions partitions its messages. This will be important a little bit later, and also, of course, you have to you can guess. Yes, you can send messages to different Kafka topics. It doesn't have to be just one. So, as I promised, Kafka Samza has a really simple API. You have to implement only one interface, only one method, 3 parameters. Let's take a look how it works in practice. So, what we will see in the demo, we'll see a Samza task that consumes tweets from Twitter and then just puts them into a Kafka topic. Okay, so I did promise you a single class, right? And there are a few more. And why is that? Well, first of all, I had to implement my own consumer from Twitter. It doesn't exist in Samza. And that's why we have these 3 classes right here. And the first class, it's a simple Twitter client. It's a custom class. It just downloads tweets from Twitter. So I'm not going to go into much detail. The other class, and now this is where things get interesting. This is a Twitter consumer class. It extends a blocking envelope map class, as you can see here. And this blocking envelope map, it's a class that simply implements the interface called system consumer. And as you can guess, the system consumer, if you remember from Kafka consumers, it simply consumes messages from a particular system, in our case Twitter. And this interface, system consumer, has 4 methods. It has the method start, stop, register, and poll. Start and stop you have to implement by yourself if you're using envelope map, blocking envelope map, and blocking envelope map implements for you the register and the poll method. Register method is used to register streams and partitions of streams to our Samza job, or actually, yes, the Samza job, so it could send messages to our tasks. And then the poll method is also implemented, and it's used to send messages directly to our task. And we have to implement the start and stop methods. And as you can see here, start method is just used to start downloading tweets, and the stop method is used to stop downloading tweets. And the final class that we have to implement so that we would have our own custom consumer is the system factory class. And why is it important to have the system factory class? As you remember, Kafka has producers and consumers, and this interface, let's say, unifies all of this. You have to implement a system consumer, so you have to implement this method that gets you a consumer. You probably would want to implement a producer for a certain system. This method allows you to get the producer. And finally, this is something new. It is Samza's. System admin is, let's call it the helper class that allows you to get information about the system that's underlying. So, and now to the good stuff. So, here we have a Samza task that is as simple as it can be. As you can see, I have only implemented one interface. I have implemented only one method, and it's really simple. You get a message, in this case a tweet. It's contained in this incoming message envelope. It also has some other information other than the message. It contains, let's say, information about the system, about the partition, and so on. Then you have this message collector object. It's used to send messages to other streams. And then you have a task coordinator object. It's used to interact with the Samza job. It's used to commit checkpoints manually, to stop running the Samza job, and so on. Usually you don't mess around with this one unless you really know what you're doing. And what we're doing here is simply getting the tweet, then mapping it using Jackson, and then just getting the text out of the tweet and putting it back into Kafka. Let's see how this works. I'm going to start the Samza task now. Hopefully the internet will hold. So I have started the Samza task. We can see right here that it's running. We've called it the Twitter Reader Java 1. And I'll show you how the name was determined. And right now you can see that it's accepted but still not running, and now it's running. So let's see if we can consume the Kafka topic and see what tweets we're getting. And if it's not working, it's, oh great, it's working. And as you can see, tweets are coming in, everything works, everything is nice with the world. And let me just show you exactly how we started this. You have to prepare a config file. That's how you tell Samza what you want to do. And there are some things that you have to explain to Samza. And we're just going to go over the basics. So you have to tell it which task you want to run. It's the task that I have just shown you. You have to explain to it what systems you're going to use. This time we're using Twitter. Next time it will be Kafka. I'll show you that one. And also you have to explain to Samza what other systems you're going to use. In this case, we're using the system called Kafka. So it's because we want to send messages to Kafka, right? And so we have the Twitter system for getting messages and the Kafka system to produce messages. So that's all nice and well, but what if you want to use Samza, for something a little bit more complicated? Then you have more flavors. You have an initiable task, you have a closable task, you have a windowable task. Initiable task and closable task, the name explains itself probably. Initiable task has a method called init that is called whenever a task is started, and you can do anything you want in it. It's a simple Java method. And the closable task again has the close method that's called anytime task is stopped. And the interesting one is the windowable task. It has a single method again. It's called window. And this method will be called at configured intervals. So let's say every 10 seconds or every minute. And then you will receive again a message collector and the task coordinator. But as you can notice, you're not getting. I have the one. Just a second. But notice that you're not getting an incoming message envelope. What does this mean? It means that if you want to use the windowable task interface, then you have to collect messages in this method, and then when this method is called by Samza, the Samza job, then you have to do something with the message, if you want, of course, with the message that you have collected so far, and then output the result, let's say, to Kafka or any other system. And what's really important to know here is that Samza uses a single-threaded model, meaning that there is no chance that your process method will be called during a window method. So there is no chance that you get some messages, miss them, or count them, let's say, in that window when it didn't happen in this window. And Samza, they're similar in my mind, Samza allows you to leverage some of the best features of Kafka by using managed states. And I'm going to skip this slide, then come back to it. So you have this image. As I said, Kafka has offsets, and we have a partition right here. You can notice that a partition doesn't have to have the same number of messages on it as all other partitions, and offsets are different. But so these 1, 2, 3, 4, 5, and so on, these are offsets. And a Samza task has managed to read, let's say, 5 messages, and currently it's processing the 6th message. And then it fails. What happens then? How do you restart the Samza task? Well, one option is that you just continue reading from the end, but then you lose messages 7 and 8 and possibly message 6. Okay. Oh, but now we remember that Kafka allows us to read messages in any order and from any place. Okay, then so we can read from the beginning, and then we can process everything again. And that's fine if you want to do that. And Samza allows for that. It's called bootstrapping. But usually what you want to do is continue reading where you left off. And that's what Samza allows you with checkpointing. So how does checkpointing work? Well, a Samza container, or actually the Samza job, but per Samza container, by default, you have on the disk all the checkpoints or all the offset are stored. So this, let's call it a checkpoint store, is per machine and for all Samza tasks. As you see, each Samza task has its own checkpoint, but Samza allows you to store these checkpoints in Kafka, and then each Samza task will get its own let's call it message on a Kafka topic, and then this really ensures that your offset, your checkpoints are not lost. Why? Well, because Kafka is replicated, but this container is not. So if an entire container fails, then checkpoints are lost. So what you can do is store these checkpoints in Kafka. And by extending on this feature, Samza figured out that it would be best to enable stateful stream processing. And how does Samza do that? Well, it allows you to create stores. Okay, by default, if you have some processes, then yes, perhaps you could create your own store, an external database, an external file system, or something similar. But then the performance of Samza, or whatever system you're using, is going to be limited by the performance of the external system. And how does Samza solve this? Well, it's quite simple actually. It creates for you a local store, so each Samza task has a local store. It is a part of the Samza container, so if the Samza container fails, then the local store will fail as well. And I'm going to explain how we can mitigate this. But as I said, each task has its own store, so it's not shared between the tasks. And Samza comes with 2 flavors of these stores. It comes with key value stores and document stores. Actually, these document stores aren't available yet. Hopefully they will be from the next version. And these document stores have been developed in Levi 9. I'm going to talk a little bit about them more in a few minutes. But these key value stores, they also come in several flavors, and the most used one are RocksDB. It's an in-memory database that also dumps data to disk, and also you have the plain in-memory implementation. So, how do you keep these stores if they're on the physical machines? Again, Kafka to the rescue. So, we have a Kafka topic that we're consuming messages from. We have our tasks that are processing these messages. They are storing them locally. But in the background, Samza is replicating these local stores. It's putting the transactions or the changes that happened in the store it's storing them in Kafka, and again Kafka is replicated and is partitioned, so these changes are not going to be lost. And furthermore, if you're afraid that, let's say, a local store receives, let's say, 1,000 queries per second, but only holds 10 keys, it's possible, why not? Then you can use a feature of Kafka called log compaction. What does it do? Well, for each key that it receives, it only stores the last message. So if you have a key, let's call it ID, and you send 10 messages holding ID 10, and the last one, its value is 15, then Kafka will only remember that message. And these stores are really important. They do not only enable stateful stream processing, they also enable meaningful joining of streams. And what do I mean by meaningful joining of streams? Well, okay, yes, you can simply use a task, and I'm going to show you how to join two streams, but okay, then you're doing this blindly. You're just putting messages from one topic and from the other topic into a new Kafka topic. But if you use these stores, then let's say you can store user data, and then if let's call a friend of this user that we have data about comes along, then we can join these two streams in a meaningful way and then output the result in another Kafka topic. And this is precisely what the next demo will show you, or let's call it a simplification. Again, we're going to download tweets from Twitter. We will have one, the Samza tab that I have showed you already, processing the downloaded tweets, putting them into Kafka, and the other one processing other tweets, putting them again into Kafka. Then another Samza task will simply join these two Kafka topics and output the result into another Kafka topic. And let's see how it might look like. Yep, great. Okay. So it's really quite simple. As you can see, I only implemented the interface, and this I've implemented just to show you how it works. And this is how joining streams looks like in Samza. You just receive messages, you don't really know how, you're just getting them. It doesn't matter from which system they're coming from. Maybe it's Twitter, maybe it's Kafka, maybe it's something else. And then you can check actually from where you're getting these messages from the by getting data from the incoming message envelope. You check it, and right here we're incrementing counts for Java and Scala, and I'm going to show you why in a minute. And then simply you pass all the messages along, and you have effectively joined Kafka streams. And right here we have that method that I was talking about, the window method, and we're simply logging how many Java tweets and Scala tweets we had in the last window. And let's see how we can configure a task to read messages from two different topics, but also how to configure the windowable task. And as you will see, it is quite easy. So I want to read from more than one stream. I just add it. I want to have a windowable task that executes each 10,000 milliseconds. Then I just add this line, and that's it. So let's see how it works. So first I'm going to start our Twitter reader only for Scala, so I can get tweets for Scala as well. Then I'm going to start our task that joins these two streams. And we can confirm that they are running by simply checking here. Okay, so one is running, one is still only accepted. And now all three tasks are running. And let's see if we're really getting these messages. So, as you've seen, I'm reading from two streams. I'm reading from Twitter Java stream and Twitter Scala stream, but I'm outputting the results, the messages from these two streams, the stream called Twitter JVM. And now you'll see here messages coming along from, sorry, it's probably a little bit confusing like this. And now I'm getting tweets from for both Scala and Java. And right here I can check how many Samza tweets I have, Scala tweets I have received, and how many Java's, oh, still working, okay. And how many Java's tweets I have received. Sorry, for some reason it's a little bit slow. Okay. I just go to the container that is running the Samza task. I check its log. Let's go to the end. And let's find it somewhere. Okay. So in the last window, and remember it's each 10 seconds, I had 3 tweets about Java and 0 tweets about Scala. But in the next window, I had 5 tweets and 0 tweets, and it seems nobody likes Scala. Okay. But, as I said, if we want to do some meaningful processing, we have to use stores as well. And key value stores in Samza are really, really simple. They allow you to only query by key. It means that if you query by key, the value is either there or it's not there. And then, if you want to do something more complex, like, okay, did the message contain these words near each other, then you have to get a little bit creative. And we have been influenced and inspired by the work of Martin Kleppmann and Alan Woodward, and decided to add Apache Lucene and Flax Luwak frameworks to Apache Samza and turn them into a custom API called the Document Store API. This Document Store API allows you to join tasks on more complex criteria, but also it is a precursor for SQL-like query language for Samza that it currently does not support. So, just a few words, what are Apache Lucene and Flax Luwak? Apache Lucene you've probably heard about, maybe you know what it is, maybe you don't. Just a few words. Apache Lucene is a document store. It works by taking documents, breaking them into words, doing something with these words, and then storing the result. And then you create queries. So you had, let's say, a book that contains the word voxed, and then you say query, okay, give me all the documents that contain the word voxed. That's how Apache Lucene works. And Flax Luwak turns this concept on its head. You are no longer storing documents. This time you're storing queries. And then you give a document to Luwak, and then it tells you all the queries that this document matches. And we can leverage these features of Luwak to create endless possibilities in Samza. So if you have a stream, you create a query that says, okay, give me all the messages that contain, let's say again, voxed, and then you have a nice little stream of, let's say, news articles that contain the word voxed, but now you're only interested in news articles that are talking about Samza and Voxed. And then you just say, okay, give me all the documents or the news articles that contain Voxed that is near the word Samza. And this is precisely what I'm going to show you in the next demo. So again, we're going to download tweets from Twitter. We're going to do something with them, put them into the Kafka topic, do something with those tweets again, this time with Luwak, and then we're going to output the result into another Kafka topic. Sorry. So, let's see how you operate with document stores in Samza. And this is a little sneak peek. It's not yet publicly available, but hopefully, as I said, it will be soon. And this part is completely the same as before. You just implement the process method. Here we have implemented the initiable task interface. And right here in the init method, we're, let's say, getting the store out of Samza. And then here, right here, we are telling our document stores what we are searching for. This is simply a key that I have decided to use for the query. It has nothing to do with the actual query, or it's only its ID. And right here, I'm telling Luwak to find me all the documents, or sorry, to match the documents that have a field name text and the word Samza in them. And how do we get all these documents? Well, it's quite simple. We get the message from Twitter. We create a document out of this tweet. We have to supply the analyzer. It's the standard analyzer. It's like a class that analyzes text based on some principles, and this one is for US English. And right here, as you can see, we're adding the tweet with the field text, and we're just matching this document against the store, checking all the results, and then outputting them to Kafka. And let's see how that works. Okay. Let's start consuming the stream right now. Oh, so many tweets. So, right now I'm not hopeful that we're going to see a tweet right here, because what I'm looking for is somebody tweeting with the hashtag VDB15 and also including the word Samza. And you probably already tweeted how cool this is. You don't have to do it twice. And so I'm going to do it manually. It's called Voxed. So this is just a console producer for Kafka. I'm going to send it first a message. Okay, just Voxed. And as you can see, no messages here. But if I do say Voxed Samza, I should be getting that message here, but I'm not. What? Sorry, can you repeat that? I can't hear. Oh. It's not Samza? Ah, okay. Sorry about that. I promised you it worked. Okay. So let's try it like this. That then. Yeah. Samza. So it's probably just not working. Okay, so let me just check whether I have the right topic. And right now I'm going to explain how I created this store. Here you can see it's really simple. You just say which flavor of the store you want to have. This time we're using the Luwak document store. We also have the Lucene document store. And of course, if you want, you can implement your own document store. And that's it. Okay, here you can see that I have set the replication factor of my store to 1. And it's because I only have one machine. And it's not on several machines. So there is nowhere to replicate to. And yeah, I did the topic correctly. So let me see what I have missed here. Okay, maybe it failed. Let's check that. Nope, it's running. Interesting. So let me try that again. But I'm pretty sure it works with Samza because that's what I tested it with. And maybe I introduced the bug a little bit later. Yep, it works. Yay. So again, again, so you just can see. If I type in just Woxt, it doesn't work. But if I type in Woxt Samza, we get the message, and let me fix that nasty little thing. So next time I don't get embarrassed. Okay. And for the end of my presentation, I would like to leave you with a few extra words so that I'm not only talking about a glorified tutorial about Kafka and Samza. So I'm going to leave you with the things that we have learned so far. So you build your system, it works fine, that's great. But at some point you're going to get spikes in the data coming in. Maybe you posted some really cool article and then all of a sudden millions of users are coming in and you can't just handle that. Okay, yes, you can predict and try to predict how many users you will be having at, let's say, Saturday at 5 o'clock. And then you can build your architecture for that peak. But what Kafka and consequently Samza allows you to do is to fall behind. So you have 1 million users and you can only process, let's say 10,000 users at a time. But that's okay, it doesn't matter. All the messages, all the information about the users is in Kafka, and Samza can just go through them. And then the peak goes down, and then you have some free time, and then you will process all the data. No data will be lost because your system couldn't handle it. And another very important thing to think about when you're using systems for streaming, you have to think about idempotence. And I'm sorry if I pronounced that wrong. What idempotence is? Well, it's a quality of a function to never change states. Okay, it changes states only once. So, for example, a function is idempotent if when you first use it, it gets a value, but if you use it again and again and again, it remains the same value. So an example would be x equals 2. No matter how many times you say x equals 2, it's always the result is going to be 2. But if the function is x plus 2, then if you do x plus 2, it's going to be 2, x plus 2 is going to be 4, x plus 2 is going to be 6, and so on. And why is this important? Your tasks will fail. It cannot be avoided. But if you organize your data in such a way that aggregation happens all the way upstream and not downstream, then you may have a way of mitigating this. For example, if you're handling user data, and user data is constantly coming in, right? And you're interested in how many users you have per minute, per hour, per day, per week, per month, doesn't matter. And in the first task, you aggregate per minute. And then you send that information to Kafka. In the next task, you get these aggregations per minute and then aggregate them per hour. Then pass along that information to another Samza task and so on. You get the idea. And finally, I would also like to leave you with some wisdom that we have gained thus far. Using Kafka and streaming in general, it makes some easy things really difficult. Have you ever imagined that you have to think about how to get data from there to there? Probably not, because you never had to think about distributed systems and efficiency. But there are some things to the rescue. First of probably many frameworks that will come, it's Copycat. It's tightly integrated with Kafka. It's not publicly available yet, hopefully soon. It's used to get data from somewhere into Kafka and then get data out of Kafka and put it somewhere, maybe back to Kafka, maybe somewhere else, doesn't matter, but it's a really nice feature of Kafka that will be added, and if you're interested, please look it up. Another really hard thing is how to get the data to end users. So now you have streams of data, you no longer have relational databases. How do you get the data to users? Well, some frameworks to the rescue, Druid.io and Faceit.js. Druid.io, it allows you to query Kafka streams and then get the result back as JSONs. It could be graph data, it could be just some information, doesn't matter. And Faceit.js transforms this data and makes it more presentable. And final thing that I would like to leave you with, it's late data versus missing data. If you were doing batch processing up to this point, then if you miss data for 15 minutes and it arrives 15 minutes late, then you cannot see it. But if you're doing stream processing, then you will get late data, and then you will not understand what's happening. And you have to be prepared to, okay, so let's check all the tasks upstream. Okay, this task failed. That's why I'm not getting the data. Okay, let's restart the task. So don't be scared if you see some missing data. So if I have piqued your interest, then please check out the code that I have shown you here, only with more comments and such, at our own public repo at GitLab. And if I have really piqued your interest, then you can visit Hello Samza repository to check out all the cool stuff that it gives you, and also to learn a little bit more about Samza. And if you have any questions or feedback, please email me at art.žuljević@levi9.com or directly to the dev topic at samzapache.org. And of course, if you have any questions now, I will take them. You nice gentleman there. Okay. The main difference between Samza and other streaming frameworks is how messages are handled and how state is handled. For example, you have Apache Spark, Apache Storm. It allows you, it has almost, exactly all the features of Samza and then some more. Storm allows you to have a different delivery semantics. Samza only allows you to deliver messages at least once, but Storm, it allows you to deliver messages at most once, at least once, and exactly once. And that's the biggest difference between Samza and Storm. And Storm also handles state a little bit differently. Samza does it with local stores, and Spark does it with distributed databases. So there is a little bit of an overhead there, but it's probably the same performance regarding state. And let's see Spark Streaming. Spark Streaming is a little bit different. It isn't really streaming per se. It's what they call it is micro batches. You process messages in some small batches, and then that is the result, that is the message that you will receive. And also, this feature is used to manage state. Hopefully, that will answer your question. So, if there are no more questions, then thank you for listening, and have a wonderful life. It is the last day.